Hey everyone, I'm Dr. Ben. In this video, we are going to discuss two aspects of nutrition labels, the serving size and the listed calories per serving. More specifically, where do serving sizes come from and what do they indicate? How is the number of calories per serving determined, and how accurate is this number? Lastly, how should you use this information to guide your own eating habits? That is what we are going to explore in this video. First, we will consider where serving sizes come from. These are based on a table of values containing the reference amount customarily consumed, or RACC for short. These RACC values depict typically consumed portion sizes based on survey data. As people have consumed larger portion sizes over time, the RACC values have increased as well, such as for ice cream, which increased from 1/2 to 2/3 cups, and for soda, which increased from 8 to 12 ounces. Thus, the first step for a company to determine the serving size on its nutrition label is to consider the RACC value of its product. And since this reflects typically consumed portions, which may be far from optimal portions for health purposes, it should be clear that the serving size does not reflect in any way how much you should consume. There are additional considerations beyond just the RACC value. For example, serving sizes are rounded to match typical household measurements. Pizza has a RACC value of 140 grams, but a 1-pound pizza will list a serving as 1/3 of the pizza, which comes to 151 grams, as this is easier to measure than exactly 140 grams. However, it can vary much more significantly than this. When a RACC value is less than 100 grams, individual foods containing between 67% and 200% of the RACC value can be listed as a single serving. For example, brownies have a RACC value of 40 grams, so individual brownies weighing 40 or 80 grams can both be listed as a single serving, despite one having twice as many calories as the other. The key takeaway here is that serving sizes generally reflect how much food is typically consumed in one sitting, not how much food should be consumed in one sitting. Now let's move on to calories. Regarding the accuracy of the listed calories, there are a few things worth knowing. First, calorie counts are rounded to the nearest increment of 5 between 5 and 50, and to the nearest increment of 10 beyond that. So this alone may make the calorie label off by a handful. But this should not make any meaningful difference in the long run, as this will average out between different foods. However, there is a much larger potential source of error. Per the official guidelines, nutrition labels are legally allowed to underestimate the true calorie count by up to 20%. Why is this inaccuracy allowed? This is partly due to inconsistencies in the manufacturing process, as environmental differences where crops and animals are grown can alter their nutritional content. Additionally, for some food items, it is difficult to ensure the exact same size in every package. For example, one study looked at 24 snack foods and found the serving weight exceeded the listed weight on average by 1.2%, but 4 of the foods were off by more than 10%. However, a more significant factor is the difficulty in determining the caloric content of foods that is relevant for humans. Let me explain. Bomb calorimetry is the experimental process used to determine the total caloric content of a sample of food. A food sample is mixed thoroughly, freeze-dried to remove its moisture, and inserted into a bomb calorimeter. Inside the bomb, the sample is surrounded by oxygen, and the bomb is surrounded by water. The sample is ignited with electricity and burns, releasing its caloric content as heat that warms the water. The temperature change of the water indicates how many calories were released from the food. This tells us the true value of the caloric content of the food, but that is not what is listed on nutrition labels. Nutrition labels list the metabolizable calories, or the number of calories we can expect our bodies to absorb when we eat the food. When we consume food, we do not absorb all the calories, and some are excreted in our urine and stool. To measure how many calories are absorbed, we need to give a test food to people consistently, collect their urine and feces, put this in a bomb calorimeter to calculate its energy content, and then subtract the excreted energy from the total energy of the food source. Wilbur Atwater and colleagues around the year 1900 performed dozens of experiments like this, determining Atwater factors that describe for a given food how many metabolizable calories each gram of protein, carbohydrate, and fat provide. For most foods, the Atwater factors hover around 4 calories per gram of protein, 4 calories per gram of carbohydrate, and 9 calories per gram of fat. Fiber is harder to quantify but is usually assumed to provide between 0 and 2 calories per gram. Let's look at chocolate as an example, as cocoa is a significant exception to the general 4-4-9 rule. This is the nutrition label of a 92% cocoa bar. I'm moving the values into a table to make the math easier to follow. Using the typical 4-4-9 guideline and assuming each gram of fiber provides 1 calorie, 20 grams of fat provides 180 calories, 3 grams of protein provides 12 calories, 4 grams of fiber provides 4 calories, 2 grams of sugar provides 8 calories, and the remaining 4 grams of carbohydrate provides 16 calories, collectively yielding 220 calories. However, the Atwater factors for cocoa are not 4-4-9, rather they round to 1.3, 1.8, and 8.4. Applying the Atwater factors for cocoa and cane sugar changes the numbers considerably, and the total calories come to right around the rounded value of 190, which is listed on the nutrition label. Now let's look at a nutrition label for a different company's 90% cocoa bar, which you would expect to be fairly similar given similar ingredients. Using the same logic as in the prior example, we should expect the total calories to round to 210 using the Atwater method and 250 using the 4-4-9 method. As you can see, the listed calories are 240, closer to the value expected using the 4-4-9 method. They even say they are using the 4-4-9 method on the nutrition label. So why can companies use different methods to determine the caloric content of their food? Buried deep within the electronic code of federal regulations, you will find the answer. Companies can use several different methods to calculate calories. The first method uses the Atwater factors. The second and third use the 4-4-9 method, but treat fiber and sugar alcohols differently. The fourth uses specific food factors approved elsewhere, which may be relevant if the Atwater factors are deemed inaccurate. And the fifth uses bomb calorimetry with a correction factor for incomplete digestibility of protein. While most nutrition labels use the Atwater factors or one of the 4-4-9 methods, clearly discrepancies exist, and the accuracy of the Atwater factors has been called into question. Thus, we need to consider studies that directly compare measured calories to calories stated on nutrition labels. One study found reduced energy restaurant and frozen convenience meals on average contained 18 and 8% more calories than stated, respectively. A larger study of a greater variety of restaurant foods found on average they were quite accurate, but individually 19% contained at least 100 calories more than stated. The study I mentioned previously that accounted for discrepancies in snack food serving sizes found these contained 7 calories or 4% more than expected on average. Alternatively, a series of studies looking at nutrition labels for different types of nuts found all of them overestimated their calorie value, ranging from 16% for cashews to 32% for almonds. As seen in the example for cashews, the degree of overestimation was similar for most individuals, but varied significantly for a few, pointing to potentially significant variability between people. A few studies have looked at overall diets, finding that higher fiber intake can lead to an overestimation of calorie consumption by 2 to 11%, while overestimation may become more prominent when in a caloric deficit. A review discussing much of this literature carried out a simulation comparing the Atwater factors to the most updated available numbers from different studies, finding the Atwater factors were very accurate overall for a typical Western diet, but generally overestimated the actual calories by 4 to 6% for a Mediterranean diet and 6 to 8% for a vegan diet. The reason for the discrepancy is due to the larger inclusion of nuts, legumes, and other higher fiber foods in the latter two dietary patterns. The key takeaways here are that apart from nuts, most of the foods and dietary patterns examined in various studies find calorie counts within 20% of their stated values. The majority are well within 10%, and when people consume higher fiber diets, nutrition labels are more likely to overestimate rather than underestimate the actual metabolizable energy content. So how can you use this information to guide your own eating? Most importantly, do not trust the serving size to teach you how much of a food or drink you should consume. The serving size just reflects a portion close to the typically consumed amount in one sitting. Regarding calorie counts, you can mostly trust these. On average, when assessed in dietary patterns, they are mostly accurate, and larger inaccuracies generally come from the inclusion of nuts or high amounts of dietary fiber. As these factors lead the stated calories to overestimate the actual amount, this will not hurt your efforts if you are trying to lose weight. One study did find snack foods understate their calories by a small amount, but this will only make a meaningful difference if you eat many snacks daily. The one scenario that may significantly impact you is restaurants. Some restaurant meals greatly understate their calorie counts, and if you frequently eat those meals at any given restaurant, then you may also underestimate your caloric intake to a larger degree as well. However, even this will not be very consequential if you track and adjust your caloric intake based on how your weight changes over time. And I will discuss how to do this in detail in an upcoming video. I hope you all found this video informative, and I will see you in the next one. Goodbye.